Hello everyone, and welcome back to Mother Manada's YouTube channel. In this video, we'll be solving another math problem. Let's start. Okay, so this problem says, how many integer values of k exist if x squared plus kx plus 1 is greater than x minus 7 is true for all real values of x? So first thing I want to do is I want to move all these terms to the left side. So let's do that. Okay, now I want to group the like terms, and I'm probably going to factor these. So it's going to be x squared plus k minus 1 times x plus 8 is greater than 0. And we want this to be true for all real values of x. So when I think of this, I think of a parabola. So if we just draw a rough sketch of that, it may look something like this. And something that's important to note is that it doesn't touch the x-axis, if it's true for all values of x. Now, this might remind you of something. The discriminant. If we use the discriminant, we can say that for this equation to be true for all real values of x, the discriminant has to be less than 0 for it to not have any real solutions and therefore not touch the x-axis. So what is the discriminant? Well, the discriminant is just b squared minus 4ac, where a is the coefficient in front of x squared, b is the coefficient in front of x, and 8 is the constant. So we can just set b squared minus 4ac less than 0. And if we do that, we'll find our desired value. So if we do that, we have k minus 1 squared minus 4ac, which is 8 times 1 times 4, so 32. And this has to be less than 0. So now we can expand and combine like terms. And we get k squared minus 2k minus 31 is less than 0. Now all we have to do is solve for k. So as you know, this is going to be a quadratic, and we want to find the values where it's less than 0. So that we just have to find the x-intercepts, and all the integer values that lie between those x-intercepts will be part of the answer. So for this, I don't think there are any factors of 31 that add up to 2, so we can use the quadratic formula. So k equals 2 plus or minus 4, which is b squared, minus 4ac, so that would be plus 124, all over 2a, which is 2. And if we simplify this, we'll get 1 plus or minus 4 root 2. 4 root 2, that's greater than 5. So, and it's not asking us, it's asking us for how many integer values of k. So we can substitute this as 5, so that'll give us the least integer that's still within those bounds. So if we do 1 minus 5, we get negative 4. And if we do 1 plus 5, we get 6. So now all the integers between negative 4 and 6 inclusive will make this equation true for all real values of x. So all we have to do is find the range. So 6 minus negative 4, and we have to add 1 because we're including both values. So that would just be 6 minus negative 4 is 10, plus 1 is 11, giving us our final answer of 11. And we're done.